Hello class, welcome to lesson 10.8, which is all about trigonometric ratios. By the end of this lesson, you should be able to find trigonometric ratios of angles, and you should be able to use, not fuse, you should be able to use trigonometry to solve triangles. One thing I'm going to say multiple times forever and ever because people always forget it. Sine, cosine, and tangent can only be used with right triangles. Sine, cosine, and tangent can only be used with right triangles. The other thing I'm going to say is, if you want me to yell at you in class, if you say sin instead of sine, I will yell at you. If you say cos instead of cosine, again, I will yell at you. If you say tan instead of tangent, I will yell at you. Okay? So, if you say sin, cos, or tan, I'm not going to help you. But if you correct yourself and say sine, cosine, or tangent, I am more than happy to help you, okay? So, let's talk about sine, cosine, and tangent. Some of you have been asking me about this for months already because you see a lot of really funny memes, typically about tangerines or Bill Cosby. You know, if you haven't found those already, maybe do a quick Google search. There's some fun ones. But we're finally going to learn it. So the acronym you're going to hear me say a lot today is called SOHCAHTOA. SOHCAHTOA. And we're going to sing a song about this in class, don't you worry. SOHCAHTOA, basically this acronym tells you everything that is written right here. Okay? Sine is the opposite over the hypotenuse. Cosine is, I'm running out of space. Cosine is the adjacent, which means right next to, over the hypotenuse. And tangent is the opposite over the adjacent. Okay? Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. What that means is that if I were asking you what the sine of angle A is, so see we have angle A over here, I'm going to go to the, since it's sine, I'm looking for the opposite, so I'm going to draw a line all the way to the other side of my triangle. I'm looking for whatever this number is, and I'm going to put it on the top of a fraction. And then I'm looking for my hypotenuse, which we already talked about in 10.5, and how the hypotenuse is always opposite of your right angle. So I'm going to put my opposite over my hypotenuse in a fraction. Cosine of angle A, so I'm still using that same angle. Cosine of angle A, cosine is adjacent, so the side that's attached to angle A, and it's the side that is not the hypotenuse. The side that is not the hypotenuse is your adjacent. And then I do my adjacent over the side that is the hypotenuse. Again, the hypotenuse is opposite of your right angle. So cosine of angle A is my adjacent over my hypotenuse. If I want to look at what's the tangent of angle A, so still just studying this angle, tangent is the opposite over my adjacent. So I'm going to do my opposite, which is A, over my adjacent, which is B. Okay? I highly recommend writing SOHCAHTOA on everything you own. It's really going to help you. Let's practice finding the values of the three trigonometric, sorry, it's a tongue twister, trigonometric ratios for angle B. So I look at my triangle, I see here's my angle B, and I want to know what my three trigonometric ratios are. So sine of B, okay, remember, sine, so is opposite. So what side's opposite of angle B? Oh, we have a variable. Before we can figure out what our ratio is, we need to solve for b. We have a right triangle, so we can use our Pythagorean theorem. I can say 9 squared plus b squared equals 15 squared, or 81 plus b squared equals 225. And if I subtract 81 and take the square root, I get b equals 12. So I skipped some steps in there. So b squared equals 144. If I take the square root, b equals 12. Okay, so this, I'm going to rewrite. This is 12. Now I can figure out my ratio. So sine of angle B is my opposite, which is 12, over my hypotenuse, which is 15. 12 over 15 can be reduced. 3 goes into both of those, so that becomes 4/5. And that is my sine. Now, if I'm going for cosine of B, so ca, C-A-H, that means I'm still looking at angle B. I'm looking at the side that's adjacent that's not the hypotenuse, so that's 9 over my hypotenuse, which is 15. And 9 over 15 becomes 3 over 5. And then if I want tangent of B, so tangent is opposite over adjacent. So if I go back and erase some of these things, opposite over adjacent. So I look, what's my opposite? My opposite is 12. My adjacent is the side that is not the hypotenuse, which is 9. If I reduce that fraction, I get 4/3. So those would be my 3 trigonometric ratios for angle B. Why don't you go ahead and try to find the 3 trigonometric ratios for angle B in this example? Hopefully you got that sine of B was 15/17, cosine of B was 8/17, and tangent of B was 15/8. If you have questions, let me know. Let's look at example 2. You guys are probably going to love this a lot. There is an IXL like this as well. You're just going to plug these things into your calculator. So if you look at your calculator, you're going to see a button that, as you guys call it, you say it's sin. Okay? And then on your screen, you're going to see something that looks like this. It's automatically going to open a parentheses. All you have to do is hit 3, 1. It's going to give you a 31. And you guys can actually hit enter without closing the parentheses, and you'll be okay. The biggest thing that you're going to have to be careful for is looking where do they want you to round, because you're going to get a really big decimal number. Here we're talking the 10,000. So 10s, tenths, hundredths, thousandths, 10,000ths. So that's 4 decimal places. And if I plug that in, I'm going to get 0.5150. Some of you are going to ask me, do I have to put that 0 on the end? Yes, because we're asked to round to the nearest 10,000. That'd be like writing money as like 51.5. I would ask you, where's your 0? Okay? I need you to round to the nearest 10,000. Go ahead, type in tangent of 76 degrees. Hopefully, when you did that, you got 4.0108. And when you plug cosine of 55 degrees in, you should get 0.5736. If you didn't get these answers, something you're going to want to check for is if on the calculator screens that we have in class, in the bottom right-hand corner, you should see something that says DEG. That stands for degree. If it doesn't say DEG in the bottom right-hand corner of your screen, you're not going to get the correct answer, bring that calculator to me and I'll put it back in the right mode, okay? It has to be in degree mode. Why don't you go ahead and use a calculator to solve this one. Good luck. Hopefully you ended up with 0.9945. If not, ask for some help. Alright, example 3. Solve the right triangle. We want to round each side length to the nearest tenth. So I'm going to look at this triangle. I see I have angle A is 35, angle C is 90. So angle A is 35. Angle B, we don't know yet. Angle C is 90. Well, I know a triangle has a total of 180 degrees. So if I do 180 minus 90, I'm left with 90 degrees. 90 minus 35 more leaves me with 55 degrees for angle B. Which if I ask you to solve the right triangle, that means you have to solve for anything that's not labeled in the picture. So you would have to solve for that angle. Now we have to solve for all of the side lengths. So if we look at side BC, AC, or AB, alright, AB, you can see is 7. But we have to figure out what BC and AC are. So if I want to solve for AC first, this side right here, I have to pick one of my angles. You can pick either one. You can either use 55 or 35. I'm just going to use 35 because it was the one we were given. And I have this angle. I know the hypotenuse. So I have an angle. I have a hypotenuse. And I want the side that is adjacent. I want the side that's touching my angle. So I want the adjacent. So if I look at SOHCAHTOA, which one uses the hypotenuse and adjacent? That looks like we're going to be using cosine. So what I'm going to say is cosine of 35 equals, then cosine is adjacent. In this case, we don't know what that is, so we're going to call it x. Adjacent over our hypotenuse, which is 7. And then we want to solve for x. Right now, x is being divided by 7, so I'm going to multiply both sides by 7. And if I type 7 cosine of 35 into my calculator, I'm going to get 5.7 out when I round it to the nearest tenth, like the directions tell me to. So I'm done with AC now. But if I want to find BC, so the green X, or actually let's call it M, just a random variable so we don't get confused. So if I want side M, and I'm still using my 35 degrees, I have an angle, I still have the hypotenuse. It's always best to use the information they give you rather than the stuff that you round for, like you solve for and round. And I want the side that is opposite of my 35 degrees. So hypotenuse and opposite, that looks like I'm going to be using my sine. So if I plug that information in, I'm going to get sine of 35. I always put parentheses around my degrees just so that way I don't mix up letters and numbers. So sine of 35 degrees equals our opposite, which we don't know. I'm going to call that M, over our hypotenuse, which is 7. Right now, our variable is being divided by 7, so I'm going to multiply by 7. So 7 sine of 35 equals M, which, if you plug that into a calculator, you get 4.0 once you round to the nearest tenth. Okay? So these 3 answers are all things I had to solve for in order to solve the right triangle. When the directions say solve the right triangle, figure out all of the missing information. Go ahead and solve this right triangle. Hopefully you got that. The measure of angle A is 54 degrees. The side length A, or A is approximately 8.3, and little c is approximately 10.2. If you have questions, please be sure to ask. I know this can be a lot of information at once. All right, example 4, we have the angle that a skateboarding ramp forms with the ground. Okay, so I'm going to draw, I have my ground. I'm going to have a blue ramp because that sounds fun. Okay. So the angle that the ramp forms is a 25 degree angle, and the height of the ramp is 6 feet. So the height is 6 feet. And I want to know what the length of my ramp is. So I want to know how far is it to go up the ramp. So what I have an angle. I have the side that is opposite. And if I look at this drawing, I want the hypotenuse. So out of my SOHCAHTOA, opposite and hypotenuse mean that I'm going to be doing sine. So I'm going to say sine of 25 equals my opposite, which is 6, over my hypotenuse, which we don't know yet. And we need to solve from there. So just like we were doing before, where with a variable, if we had x over 6, we would just multiply the other side by 6. We're going to do the same thing. I want to get x by itself, but first I want to get it out of the denominator. So I'm going to multiply both sides by x. So I have x sine of 25 equals 6. Then I want to get x by itself. Right now it's being multiplied with sine of 25. So I'm going to divide both sides by sine of 25. So I have x equals 6 divided by sine of 25. And if I plug that into a calculator, I get that the ramp is about 14.2 feet. Okay. I recommend drawing pictures for story problems. It really helps. Go ahead and try solving this one on your own. Hopefully you ended up with 2 feet. If not, be sure to reach out for some help, either from me or a friend. Alright, the last thing we're going to learn is something called inverse trigonometric functions. So earlier we were always given an angle measure. Now we want an angle. Okay? So this time I'm going to give you enough sides to solve in order to find the inverse, or in order to find the angle. So there's inverse tangent, inverse cosine, inverse sine. What they look like, if you have an exponent that's a little -1, that means you are solving for an angle. Same thing goes for inverse cosine or inverse tangent. So if I give you this triangle right here, and I say, I want you to find angle x, so I want you to find this angle to the nearest degree. If xy equals 14 and yz equals 5. Ooh, that is definitely not a 5. Yz equals 5. Alright, so I have this angle, and if I look at this angle, I have the opposite, and I have the hypotenuse. So if I look at my SOHCAHTOA, opposite and hypotenuse are sine. So I'm going to say sine, we don't know what this angle measure is yet, so I'm going to use x equals my opposite, which is 5, over my hypotenuse. Now, if we were solving equations and I had addition, you would undo the addition with subtraction. If we had multiplication, you would undo it with division. If we had a square, you would undo it with a square root. If you have sine, you undo it with inverse sine. So we have x equals, then you do inverse sine on the other side, and whatever your fraction is, that goes inside your parentheses. So when you're typing it into a calculator, you're going to hit your second key. In this case, you're going to hit sine. It's automatically going to give you a parentheses. You're going to do 5 divided by 14. You can close the parentheses if you want, and then enter. Once you type that into your calculator like that, you should end up with an answer that when you round to the nearest degree is 21 degrees. If that's not what you got, please be sure to reach out for some help so we can see what's going on. Go ahead and solve angle L to the nearest degree. Hopefully you ended up with 40 degrees. And that is all that we have for this lesson. So if there's anything you didn't understand, anything you want to review, please be sure to let me know. And I'm more than happy to help you, whether it's before school, during class. Just let me know. Have a fantastic evening.